What's up? What's up? What's up? Now you can hear me. Yes, I apparently I was on mute. Didn't realize it, but I was on mute. Now you can all hear me well. Yes, yes, yes. I'm doing awesome. How you all doing? Mhm. 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 What's up? What's up? What's up? Now you can hear me. Okay. Yes, All right. So that's there, and that's there. Okay. I just found a harmony in my house. Oh. Okay, so Saad, you said something earlier. They banned you for figuring out the full form of D gas. What do you mean by D gas? I don't follow that, son. Like, what do you mean by D gas? I made a short form. Oh, that. Okay. Well, that's why I made a form that you should not say the word. Oh my god. Oh my god. Like, hmm. 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 Yes, exactly. Zoom doesn't ban. Okay, shall we start? Shall we begin? Shall we? Shall we? Shall we? Shall we? Boom, boom. Okay, so Sadia, thank you so very much on YouTube. She loves the way I teach. Who wouldn't? If I'm just saying, I'm just being. I'm very humble. I just want to appear confident. Yeah. Anyways, let's start. Let's start the greatest show on earth. Yeah. And then once I conquered one subject, I'll conquer the next one. So ban hammer. Who wants to ban hammer? Why would you want to ban hammer? What is that? So when I look there, I'm gonna look at your comments. That's where my second screen is. So I look there for your comments, and this is where my screen is. All right, so I can see what I'm writing also. Yeah. All right. So. Mm-hmm. 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 Okay. Okay. So this is what we're doing. Yeah. Okay. That's what we have. All right. And then we change that to a smaller screen. There you go. Okay. That's how we're going to do this. Yeah. I got to do this for every class now. Yup. How about I do this? Yes. Dun, that way. I forget to do that. Yeah, there you go. There you go. And I'll put my face a little smaller. Put my face. I do this every class. Let's start. Okay. Yeah. That's what we're doing today. Yeah. There you go. Now you see the full face. You see the full face. Let's start. Okay. So as far as you know, yeah. Does that work out for you guys? Okay. So resume recording here. So I'm recording that, and let's begin. So hi guys, those are on Zoom, those are on YouTube. Awesome. Thank you so much. Walaikum salam, everybody. Yeah. That's cool. How the screen changed. Yes. What subject is next? Honey, what subject, Sabi? Well, there is ad math, there is accounting, there is physics. Hey, I've actually taught some of them before. So I was thinking of in the next few years, I've been teaching A-level chemistry and O-level chemistry and for 18 years and some other subjects for 10, 11 years, A-level math, O-level, 5, 6 years. And I'm thinking the goal of 2021 is to conquer another subject along with chemistry, have all my chemistry on YouTube, then add another subject on YouTube and other. So in 2, 3 years time, yeah, man. Yes. So for those of you who are watching this on YouTube, you get that. If you, I don't know how this works. Let me try this out. So those on, on Zoom. Okay. So what we're doing today is percentage yield. Okay. Now what I need from you is to tell me, is this legible for you guys? Is the writing clear? If the writing isn't clear, I'll do a screen recording. Yeah. Or is it jerky and not so clear? If it is not so clear, then I will change it. Okay. Well, walaikum salam, Chashmish. This is free. So it's not about affording. This is free. Go on Noon Academy. This is free. Shafe, hello. How are you? Okay. So yeah, I'll do that. So yeah, okay, I'll do this. Okay, tomorrow so I'll get a second camera for Zoom and then a separate camera for YouTube. How about that? Take na? That works. All right, so let's begin. Okay, so what we're doing today is percentage yield. And the reason why we're doing percentage yield is remember in the questions we had, generally speaking, we had a known, in most cases we have a known that's a reactant, and we have an unknown, generally that's, so we have a known and unknown, right? And generally speaking, but for percentage yield questions, the difference becomes this, that they give you the known of the reactant and they give you a known quantity of the product also. But it is lesser than what the reactant would have made. Now, how can I explain this easily? ठीक है? Let's say मैं बात करता हूँ nitrogen and 3 hydrogen makes ammonia. Now, in just simple terms of moles, I know that 1 mole of nitrogen reacts with 3 moles of hydrogen to make 2 moles of ammonia. That's what we know. All right. Okay. So, yeah. Walaikum salam, everybody. Rida, awesome. Abdul Qadir, awesome. Enthusiastic. Lag, I don't know. So many people on YouTube also. Shafe, great, awesome. And people are here also. Just a shout out to some of you. Arib, Arisha, Farwa, Hiba. We got some newbies today. And we got some regular oldies also. Noman, Sabir, Ramis. Hi, Ramis. Hassan, Shah, thank you for joining. And others that I'm not naming, but they're there. And later on. Okay, so let's say I tell you this. Okay, 2 moles of nitrogen react with 3 moles of hydrogen to form 2 moles of ammonia. Sorry, 1 mole of nitrogen, 3 moles of hydrogen make 2 moles of ammonia. This is what should happen, meaning that if I tell you that, okay, no, I actually took, so I took 10 moles of nitrogen. Okay? So how many moles of ammonia will it make? Now you might say, well, hydrogen ka matter karta hai, so I'll say I took 10 moles of ammonia and excess hydrogen. So let me write the 10 moles in more clearly. So I took 10 moles of nitrogen. So I have 10 moles of nitrogen. And I give you this equation and I ask you all. Okay. that, okay. Let me move this a little this side so that everybody can view it. Yeah, there you go. Take it. Take it. So now, yeah. So tell me. Come on, somebody tell me. I know you guys can. Come on. I'm waiting for you guys to answer. So 1 mole of nitrogen produces 2 moles of ammonia. Let's say I give you this equation. I'm saying, how much ammonia will I make if I took 10 moles of nitrogen? Those who are on Zoom, could you guys answer? Yeah, I got a couple of answers from YouTube. Yeah. 20. So if 1 makes 2, then 10 moles. So basically this is what you do. Simply speaking, do the ratio. You see? Oh, sorry, what was it? Where was it? I'll move this here. Sorry. Then I'm telling you that nitrogen to ammonia ratio. Their coefficients are 1:2 moles, right? So 10 moles will make how much ammonia? This comes out to 20 moles of ammonia. Okay. Yes. Good. Adisha, today is the last class for moles. Thursday we start a new chapter. Yeah. Yep. Okay. So then, but what if I said, but if I only got 16 moles of ammonia, then what I'm saying is I got fewer moles of ammonia than expected. Okay. Yeah. You call this, you could say, they use the word theoretical. How do you spell theoretical? Theoretical. Yeah. I can't even. Can you believe that stuff? Theoretical yield versus theoretical yield. What we are supposed to get, and what we get is called experimental yield. Now, in my language, I call theoretical yield what I was expected. So this is my expected answer. But what I actually got is my actual answer. And in the real world, the actual amount that we get from a reaction because of multiple things. Now you might wonder, why is this happening? Well, multiple things happen. Sometimes you can waste the product, like it flies away. Sometimes there are impurities in the reactants. So that means you did not have 10 moles of nitrogen. You had a little less, but you thought you had 10 moles. Or which is a very common thing, the reactant didn't even finish. Sometimes a reaction might not finish, and that becomes a problem. All right. So, yeah. Faizan, A-level classes are not free, but A-level videos have been recorded. They're on the channel are free. You can watch the way. Okay, Wednesday is with Abul Fazal, empirical formulae and stuff like that. Yeah. And he can take the next thing forward from there. If that's done today, then he'll take out the next thing forward tomorrow. Okay. Yeah. Fazal ul Haq, I do also earn a living also, right? Sorry, guy. Yeah. I wish I could teach everything for free. I wish. Someday. I promise to. I will. Yeah. But the videos are all free, and I've got about 400 videos on A-levels on my channel, Fazal Faizan ul Haq. Okay. Yeah. So does that answer your question, Noman? Things vary. Yeah. So anyways. Now, my last thing is, so basically, what I'm trying to tell you is that I was expecting a certain amount. We technically call that theoretical yield. Okay. But what we actually get, we call that experimental, meaning the one you got in the actual experiment. I call it the actual yield. And what we are tend to ask is this, you know what, we were supposed to get 20 moles, and we only got 16 moles, and we want to know how efficient our system is. So we find percentage yield. And percentage yield is, for me, actual over expected into 100. Or as they say, experimental over theoretical over into 100. So experimental over theoretical into 100. That's what we are looking at. All right. Theoretical yield and theoretical and experimental yield. So experimental over theoretical into 100. Now, I give an example of moles. In the real world, you get mass examples. So let me show you the way how this is done. Faizan, you can write a comment somewhere. Right now I'm in the middle of class, right? Sorry, guy. Okay, Saad, I'll tell him also. The ones he's made, I'm sure he'll do that. Okay? You can put a message up on the Mighty Network also. Okay. Now, so now, how does one solve that? Let me take the same equation, guys. So let me show you the practicality of this. I take the same equation. Nitrogen plus 3 hydrogen makes 2 moles of ammonia. This is the equation. ठीक है? और मैं आपको ये बोलता हूँ कि if 45 grams of ammonia is produced when 42 grams of nitrogen reacts with excess hydrogen, what is the percentage yield? Now, I'll give you the method to solve these questions. When you get a percentage yield question, what you should do is assume the product is the unknown variable. Even though it looks like they have given you the amount of product and also the amount of reactant. It seems very obvious they've given you that. But what I tell my kids is that what you should assume is that they have not given you the product. They have only given you the reactant. So 45 grams of ammonia, even though this is the product, and they've given that, and this is the reactant, and they've given that, what I tell my students is, if it's a product and the question involves yield, what you do is you treat the product as the unknown, even though they've given that to you. Because what they have given you is the actual yield, which is the experimental yield. Okay? Experimental yield. What you have to calculate is the theoretical yield. Okay? So if I use the technical words for chemistry, this is the actual experiment in life. आपको वो दिया जाएगा. What you have to calculate using moles and stoichiometry, the theoretical yield, which will, by the way, will be more than this value. Meaning you are going to find out the mass of ammonia made that is supposed to be made from 42 grams of nitrogen. Do you understand that? So this is your known. And then you apply the same 3-step method. Step 1, step 2, step 3. What is step 1? Known को moles में convert करना है. So you have N2, you first find the MR is 28. So the number of moles is mass over molar mass, which is 42 over 28. I believe it's 1.5. Oh, 1.5 moles. Then for step number 2, you do the nitrogen to ammonia ratio. How do I do this? This is the coefficient 1, this is 2. So 1.5 is supposed to make 3 moles of ammonia. That's step number 2 Done. Then you go on to step number 3, which is now the unknown, ammonia. Find out its mass. So number of moles is mass over molar mass. The number of moles is 3. Now molar mass of ammonia is in fact 17. That's the MR, 17. So 3 times 17 is 51. So basically, the idea what I just did was, I calculated that the 42 grams of nitrogen is supposed to make me 51 grams of my unknown, which is ammonia. So now I have made 51 grams of ammonia. So this is the amount of ammonia I'm supposed to make from 42 grams of nitrogen. ठीक है? But बना कितना है? This is what I call my theoretical yield. So how do I find the percentage? Percentage yield is experimental over theoretical into 100. Okay. Now, can somebody tell me that? I seem to have a lower engagement today. Are you guys that done with moles? You know, everybody's kind of like whatever. So basically this is what I got, what I'm supposed to get into 100. And if you ever forget which is the numerator, which is the denominator, it can never be that you can never have more than 100% yield. So it'll always be the smaller number over the larger number. That's the case. So you'll never have a problem that way remembering that, will you? Yes, Abdullah Agha. Oh my God. Oh my God. Somebody has raised their hand like 15 times already. What are you raising your hand for, son? Yes, please. Abdullah, I didn't mention it. It was in the question. The 45 grams is what we actually got. We were supposed to get 51. This is the question about percentage yield. A percentage yield question really means in the real world, you're never going to get exactly what you expected from the 3-step method. So if you were to carry out the whole experiment and you got a lower value in the actual experiment, but you had a larger value from the theoretical value, so expect experimental over theoretical into 100 is what we call the yield. Like you were accurate for that much engagement. All right. Samina, I have made a video on solution chapter, molarity, absolutely. But Raoult's law and molarity are not part of A-levels or O-levels, so I'm not concerned with that right now in my life. Somebody asked that question on YouTube, please ignore that. Okay? Yeah. Moving along. Anyways. So, we got this. Does it answer your question? All right. Yeah. Okay. Yeah. Yes, Mr. Smart, waiting for what? Anyways, should we want to do another question? I can do another question. Okay, we can take one from the past papers. If you were to allow me to do that, take one from the past papers. Past papers on moles. Now, let me find a question on okay, yes, let's take another one. How about? Mr. Smart said, what? I have no idea what he meant by what. I'm both split between a now and humming again. Okay, yeah, so let's get back here. Let me give you this. Do you want to try this question out? Similar one. Okay, so nitrogen and 3 hydrogens make ammonia. So what is the percentage yield when 60 grams, let's make it more fun, when 600 grams of ammonia are produced from 600 grams of hydrogen? All right, try this one out. Okay, I don't know if you guys can see this, but it's there now. Yeah. So try solving this question. I'm gonna wait for 2 minutes for you to solve it, and then I shall solve it. All right, but for now, yes, let's you pretty guys solve this one. Come on, everybody. I know you're tired of moles, but understand that. So we already bored of moles and making it more boring. I know, but I don't care if it's boring. My job is not to really make you love everything. My job is to make it easy. Remember, when things become easy, doing it twice makes it boring also. So when you start becoming bored of something, it implies to me that you have been understood and you're done with it. So today is the last class, but this is something that we haven't done yet. So I gotta do this one, and then we move on to 2 small other things to do. But come on, try this one right now. Please. Noman, you were the one getting half the questions wrong the last 3-4 classes. So stop being so bored. Okay? Let's go. Thank you, Zanoon. I don't even know if Zanoon is a male or a feminine name. Zanoon Jawad. If you could tell me. It's a very beautiful name. I just can't figure out if it's male or female. All right, male. Cool. Awesome. Sorry. See? That's why I didn't want to assume that, Noman. Come on, guys. Lord of the Whales is the kind of Lord I want to be. Hassan Shah, I think you're right. I think you're right, son. I think you're absolutely right. Abdul Rahim, that sounds about right. Mesam, no, Mesam. No, Mesam. Done? Yes, Asba, because that's not the right answer. I think you took the MR of hydrogen as 1, Mesam. That's the only reason I can come up with to... Anyways, moving along. Okay. Okay, moving along. So where are we now? Yeah, so what do we have? So how do we do this? Well, again, the answer is 17.6 something, right? That's the answer. Now, what is the percentage yield? निकालनी है आपको of ammonia, because that's the product. So ammonia is your unknown, okay? Unknown, and hydrogen is your known. So step number 1, you find the moles of your known, that's hydrogen. And number of moles is mass over molar mass. Okay, mass over molar mass. Mass is 600 grams, molar mass is 2, because the MR is 2. Those who are getting near 33, that's because they're taking probably the AR of hydrogen as 1. The AR is 1, but this is hydrogen gas H2. Yeah. Well, if I get a millimeter plaza overnight, I'd come kiss you wherever you are, Noman. Yes, that's what I would do. I'm not going to get that, so that ain't going to happen in one day, please. In no way in hell is that going to happen. Anyway, so this is how many moles? 300 moles. Then hydrogen to ammonia is 3 is to, oh, screw it. I am so sorry, guys. I forgot. I've been giving the same equation 3 times and I forgot the 2 here. My bad. For those of you who are doing, I am so sorry. This was 2 here. Crap. Did I made a boo-boo? So 200 moles of ammonia. Yeah? Sorry about that, guys, if I threw people off. Number 3, ammonia ka mass nikalna hai. So what we do is number of moles is mass over molar mass. Number of moles is 200. Molar mass of ammonia was 17. So basically 200 into 17 is what I'm supposed to get. And that is supposed to be 3,400 grams. So what's the percentage yield therefore? I got 600. I was supposed to get 3,400 into 100. So 600 over 3,400 is 17.647 or 17.6 decimal. Yeah. Okay. No, you don't have to do it again. It's okay. Yeah. Okay. Done. All right. Then. Okay. Done. Next up, percentage by mass. Okay. So we got this. Can we do this? Can I assume that you guys understand percentage yield also? Or is there any more else that you guys would like to do? One more, maybe? One more? Imagine we understand the entire chapter. Do I have to imagine that? Why? I don't work like that, no man. There's a reason why I'm good the way I am. Okay? Good comes with excellence, not with speed. Remember that. If I was running the 100-meter marathon, I'd need speed. But I'm not. I'm teaching chemistry. It means making sure everybody in class understands what I'm doing, or doing it enough times to make sure as many of you can understand that. So let's look at this question. Okay. Now this is an organic question, and organic mein bhi moles aate hain. Okay. So yeah. So now once you do organic chemistry, you will be knowing what they're called. But let's say I tell you that this is called bromoethane, and the one on the right is called ethanol. Now ethanol. And if you can't read them, I'll write them again to be a little more clearer. Okay, in white. C2H5Br. And ethanol is C2H5OH. Okay, the first thing you should do is find the MRs, all right. Okay, then what do we have? Okay, Hey, what happened to? Yeah, hi. Mm-hmm. 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 Are you all here? Okay, so significant fingers, 3. 3. Yeah. Now, what we have is my question, which has disappeared somehow. Oh God, sorry. Running too many screens at the same time is a little difficult. Yeah. Where did it go? Yeah, okay. So this is what we have. So the idea is that percentage yield of ethanol nikalna. Say, okay. So the question is, in an experiment 10.9, and this is from a past paper, 10.9 grams of bromoethane makes 3.45 grams of ethanol, and find the percentage yield. Okay? And what they've done it easier for you guys is they've given you the MRs. So the MR of C2H5Br, they've given it to you, so you don't have to do the math for it, is 109. And the MR for C2H5OH is 46. Okay? And C2H5OH, ethanol, is your unknown. So this is your unknown, ethanol. And your known is bromoethane. This is your known, that's your unknown. Okay? And then using that idea, can you find, I'll give you 1 minute, can you find the percentage yield? Okay? And because it's an, yeah, can you give me the percentage yield? How about that? Could be 75, I don't know. Let's see, let's all of you do this. Give it a minute, come on. Then we move to the next thing. All right? Come on, come on, come on, come on, come on, everybody. Everybody, everybody. Can I check? You think I need to do the work? Oh, come on, man. He wants me to do the work. How sad is that? Okay, fine. I'll do the work. Hi, Taha. How are you doing, Taha, on Facebook? Or YouTube, sorry. Yeah. No, I don't have it open all the time with me. No. What? That would be so cumbersome to have the marks me open for every question I find. I don't have it with me right now. No, sir, Bob. 1 next 1 next 4.6, so 3.45 out of 4.6 is 75%. Oh my God, absolutely. It is 75%. 75%. You are right. Anybody not getting that? No, anybody not getting that should find a little bucket of water to drown themselves in, because it is so easy. Following? Yeah. Okay, Sabi, I have cringe. Why you? Oh my God. Cringe. Ramesh, I thought you were my fan. This is not how fans behave. I am a little upset with you. It is not becoming of a fan of me. Yes. What is wrong with you, son? Yeah. So, what's next? Okay. So now this part is done. So the next law, so one we've done percentage yield. I'm assuming nobody has a problem with that. So, yeah. I know, Farwa. Thank you for laughing at that. Oh, awesome. Okay. Alrighty, everybody. So, okay. Moving on to the next thing. Percentage composition. Now, this is generally done by mass. Now, this part is easy, just that we haven't done it, so I've got to do this also. Okay. Saad, I have many, many true friends. You can be one of them, but you can't be the only one, son. Sorry about that. Yeah? Yeah. Yeah. Mm-hmm. Mm-hmm. You mean like that? Like that? No. No. Like this? Yeah. Okay. So Ibrahim, Sohail, percentage purity is calculated the same way. So it's done the exact same way. Okay. Yeah. I didn't mean to roast you. That was not the point here at all, by the way. Okay. So now listen, guys. So let's take our last example. Okay. So what do I mean by percentage purity? Okay. No, Saad, don't be sad. That doesn't go with your name well. Okay. So guys, percentage composition is this. Let's say मैं पिछले वाले सवाल की बात कर रहा था. उसमें एक कंपाउंड था ब्रोमोइथेन जिसका फॉर्मूला था C2H5Br. ठीक है. And actually forget bromoethane. Let's take ethanol. It's more popular, which is C2H5OH. Now what they can ask you to do is this, guys. What they can ask you to do is find the percentage by composition. I might say, guys, find this for me. Percentage of carbon in ethanol. What it means is that if you take the mass MR of ethanol of C2H5OH, which is 12 for each carbon, there are 2 of them. There are 6 hydrogens, 5 and 1, 6, and then there is only 1 oxygen. So 2 carbons, 6 hydrogens and 1 oxygen. And when you find the MR, it comes to 46. And percentage composition of carbon in ethanol just means this: the mass of carbon over the MR, or more correctly, formula mass. Because for ionic compounds it can be also there, into 100. That's simply it. So here, what do I have? That would be how much mass of carbon does this compound have? This has 2 carbons. So the mass of carbon in this compound is 12 times 2 over 46 into 100. So you got 24 over 46 into 100. That comes out to 52.2%. Correct through 3 significant figures. Yep. That's how you find percentage composition by mass. Okay. Let's do another example. Okay. I'm going to switch this now. Let's take another compound. Let's take ammonium nitrate. So let's say I ask you, what's the percentage by mass of nitrogen in ammonium nitrate? This is ammonium nitrate, NH4NO3. Now, how does one do this? You first find the formula mass, which is the same thing as MR calculation. So you got 1 nitrogen, then you got 4 hydrogens, then you got another nitrogen, and then you got 3 oxygens. And when you do this math, 14 plus 4 plus 14 plus 48 is 80. So the percentage of nitrogen here is going to be all the nitrogens. You got 1 and 2 nitrogens, you see. So it'll be 2 nitrogens, 14 times 2 over 80 into 100. That will be 28 over 80 into 100. And you might think, well, why are we doing this at the end? Why not we do this at the start? Because I forgot to do this earlier. This should have been done with MRs and I forgot to do this, and I'm doing this at the end. All right? Yeah. I know, KKK. Okay. What about A2? What about A2? A2 comes right after AS, before university. What about it? Are you asking me why aren't I teaching A2? Well, I am on another platform. Second, my videos are already online on my channel. Search for them. There are many for A2s. Else, I'm teaching A2s on the Teaching Circle platform. Here, I only do live for YouTube for O levels. Yeah, sponsored by Noon Academy. That's the goal. They're my sponsors for O levels. Yeah, so they help me help you guys. Okay, Abdul Hanan. Hey, Abdul Hanan. There you go. So he wants to see both of them. So can you see both of them? Yeah? Yeah. Could be, yeah. Past papers are like, so easy. Come on. Anyways, fine. Then okay. Then okay. So. That's it. That's percentage composition. Get it? Next up. What do you want to do next? What do you want to do next? We are done with this chapter also. Now, yeah, one thing we are left is empirical formula calculation. Any questions about this, guys? I'll also tell you what our sequencing of the next few chapters are, so that you guys are prepared, okay? We're going to start accelerating stuff, and this next week onwards, we'll be getting a 1 video lesson a week also in addition to the live classes, okay? So, I'll show that to you also. Kahan gaya? Yeah. Could I please explain percentage purity? Okay, I'll do a question on percentage purity. Fine, I'll do that one. Yeah. Okay. So, for example, I'll do percentage purity. Fine. I'll do percentage purity. ठीक है. So what this fellow means about percentage purity, okay, is this. Where is it? Yes. Hi guys. Can you see my screen? Yeah. Okay. So it says here, let's say I say okay, how about this? Chalk is impure calcium carbonate. All right. Okay. So 23 grams of chalk is found to have, let's say, 0.226 moles of calcium carbonate. What is the percentage purity of chalk? Now, percentage purity, you could say simply like this, is the pure substance. So you could say mass of pure substance over mass of mixture or impure substance into 100. So here, how could you do this? Well, you've been given this many moles of calcium carbonate. So your job is to convert that into mass. So first you'll find the formula mass of calcium carbonate. पहले आप ये करेंगे, and that's 40 plus 12 plus 48. That comes out to 100. That's the formula mass. सही है? That's the formula mass. So how do I find the mass? Number of moles is mass over molar mass. Number of moles बताए गए थे हमें 0.226 gram moles हैं, और mass कितना है? Molar mass is 100. So when you do this mass comes out to 22 point. What does it come out to be? Sorry, what does it come out to be? 22.6 grams. So percentage purity would be the pure mass 22.6 grams over the initial impure mass in 200. That's how you find percentage. Thank you, Rida Fatma Kazmi. I am glad that you find this class awesome. It's supposed to be, today's a pretty dry class, by the way. It's not the best class we've had. We've had better classes than this, but the point was that we are killing moles. Remember, every time I hear a parent talk about chemistry, they tell me their kid, oh, he's so scared of moles. Moles are so bad. And today, we just killed moles. That was the whole point of all of this. If it's boring, I couldn't care less today. Today, I wanted to make sure we all got it. All right? Now, if anybody wants to know the difference between purity and yield, yield is applied to the product. Purity is applied to the reactant. Okay? I'll tell you, Saad. So since I'm on this question right now, I want to nail it. Is that somebody asked KR, how do you do this? Okay. Where is it? So are we ready? So this is question, all right? Okay. Let's say I tell you that, okay, I tell you that 5 grams of limestone gives, okay, you got to give me some time. 1 second, I'm making up a question, right? So let me give the equation, by the way. Calcium carbonate plus 2HCl makes calcium chloride plus water plus CO2. Okay, into gives 9,609 of hydrogen gas with excess HCl. And then I tell you limestone is impure calcium carbonate. Find the percentage purity of limestone. Now, if they tell you that uski nikali hai percentage purity, that means that is the impure form. Whatever is the impure form becomes your unknown. So that's your unknown. So basically, the chi that we have to find becomes your unknown. And what else have they given you? 960 cm cube of hydrogen. That not hydrogen gas, sorry, I meant was carbon dioxide gas, sorry. That is your known. So 960 cm cube of CO2 is your known. So what you want to do is find the mass of your pure substance and then apply the ratio. Ibrahim, now that means step 1, ratio more mass of this. Then find the mass of this, and then that mass over the impure mass into 100 is percentage purity. Could I ask you guys to do this? Do you want to try this, or should I do this? Okay, Sabi, you're right. But I'm asking for others. You're right. Yes. Others? Hello, guys. Come on. Can you try this in 1 minute? And then I'll do this. Anybody else? Yep. Yep. Ibrahim, 80%. Absolutely. It is 80%. You guys are beautiful. Absolutely. So the first step you do is the first thing you do is find the moles of CO2. So number of moles is volume over 24,000 cm cube if you are in cm cube. So 960 over 24,000, which is how much? 0.04 moles. And the ratio is CO2 to calcium carbonate is 1:1. So 0.04 is to what? Therefore, the moles of calcium carbonate are 0.04 moles. Then I want the mass of calcium carbonate. For me, the formula mass is 100. We did that in the last part, so that's easy to take from there. Then, what do we have? So number of moles is mass over molar mass. Number of moles is 0.04. Mass over molar mass is what? 100. This gives you 4 grams. So basically, percentage purity is 4 grams is calcium carbonate. 5 grams was the limestone into 100. That gives you 80%. And yes, that is fire. Absolutely fire. Did you guys get it? Did you? Yeah? Yep. That's it. That's the class. That is the class. All right? Yes. And that means that we are done today. All right? So Abul will do empirical formula with you guys, empirical and molecular formula questions, and any problems you might have. Otherwise, he'll start the next thing. And what I'm doing next is, periodic table of reactions of group 1 and group 7 halogens. Because once you've done moles, now we're doing types of chemical reactions. Meaning, first we do the periodic table, groups 1, group 7. Then the idea is reactivity series of metals, displacement reaction, redox, extraction of metals, then acid bases. Once we do that, then we go to electrolysis, and then energy, the rate, equilibria, organic, then atmosphere, or air, oxygen, all of that stuff. All right? Does that answer your question? So, yeah, done. That's what we are planning to do now. Okay? All right. Ciao. No? Bye-bye. That didn't work out too well, did it? Yeah. Okay. Bye.